Let's talk about the area of triangles. So triangles come in many shapes and sizes. This would be an acute triangle. This would be a right triangle. This would be an obtuse triangle. Right? But they all share a common formula. So the area of a triangle, is half times base times height. So write this down. This is going to be the key formula we focus on in this video. The area of a triangle is half times base times height. In a previous video, we talked about the area of parallelograms. So if this is a parallelogram, we said that the area of a parallelogram is simply base times height. So this would be the base here, and then the height would be this vertical line perpendicular to the base. Now, can you see any similarities between these two formulas? If a parallelogram's area is base times height, and a triangle's area is half base height, they're very similar, right? The only difference is the half. Now, why is this half here? Think of it like this visually, okay? So imagine that this triangle fits perfectly inside this parallelogram. Imagine that, okay? So here's what we could do. If we had a parallelogram and we cut it in half, so again, it's a little hard for me to draw precisely, but you can see the relationship here. This triangle is half of this parallelogram, right? So if I shade this triangle light green, we could take this triangle, put it right here. So I'm just kind of zooming in right here, okay? The triangle is half of a parallelogram, assuming the parallelogram had the same base as the triangle, okay? Same base. So this is why visually you can see the relationship. A triangle is half of a parallelogram. If you took a triangle and doubled it, and flipped it over, you could form a parallelogram with it. So visually, that's why this works. Okay. So let's actually just do a couple of practice problems with this formula. Hopefully, the area of triangles is going to be a little easier than with parallelograms, because triangles are very familiar shapes for you. So imagine we have 3 slices of pizza. So this is slice 1, and then slice 2, something like that, slice 2, and then slice 3 is going to be similar to slice 1. Alright, and bases. Let's set this one to have a base of 3 inches and a height. So the height of a triangle would be from this vertex right here perpendicular to the base. So height straight down, okay? Straight down, so it would be a right angle. The base, the height would be 8 for this one. 8 inches. For our second slice of pizza, base is 4 inches, height is 6 inches. And then for our third slice of pizza, the base is 4.5 inches. Yeah, so make it a little wider there, 4.5 inches. And then the height, let's say 7.25 inches. Okay, let's find the area of this first slice of pizza. So area equals half times base times height. Remember the commutative property of multiplication. We can actually switch the order around. We could say half times height times base. That would work too. Okay, so half times height, 8 inches, times base, 3 inches. Half times 8 is 4. 4 times 3 is 12. So the area of this first slice of pizza, this triangle, is 12 inches squared. The second one. Area equals half times base times height. Half of 4, half times 4 is 2, times 6 is also 12. And for our third slice of pizza, half times base times height. Okay, let's actually do this. This one's going to take a couple more steps. Okay, so half of 4.5 is 2.25. Say 2.25 times 7.25. So our final answer is going to have 4 decimal points. Okay, because 2.25, 7.25. All right, let's multiply this out. 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 2, 10 plus 1, 11. 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1. 2 times 2 is 4. 7 times 5 is 35. Carry the 3. 7 times 2 is 14, plus 3 is 17, plus 1. 7 times 2, 14 plus 1, 15. So add it all up. 5, 2, 11. Carry the 1, 2, 6, 13. Carry the 1, 6, 1. With 4 decimal places. And let's just round it to the 10th place. 16.3 inches squared. There you go. We're done.